So we're speaking on behalf of 7 other people as well, and you can see their names there. Kevin and Elchin are our Permafrost scientists, Peter, our semantics expert, Hannah, a developer, and then we have Haldor, Jean-Pierre, and Boris at GTMP helping us out. So in the spirit of full disclosure, as I said, I'm not a permafrost scientist, but I figured we might have a diverse group of people in the room. So before we get kind of talk about the data stuff, just a quick introduction into what we're thinking about when we're talking about permafrost. So the 2 variables that we're really interested in studying is active layer thickness and permafrost temperature. So you can see a picture of active layer thickness there, essentially the maximum thaw depth in the summer, a very important variable for understanding how permafrost is changing. As you can see, permafrost is like concrete. You can see somebody with a jackhammer there, so making data collection in the field pretty difficult. So the other thing about permafrost is that you can see from this map that it's pretty widely spread throughout the Arctic. We have a lot of ground to cover when you're talking about data collection of permafrost, trying to understand how permafrost is changing or how permafrost is operating over this really, really wide scale. Making the use of many different data sources from many different researchers really important. Permafrost has, the reason we study it, or the reason that people like Kevin and Elchin study it, is that it has really important implications for both our natural and our human environment and infrastructure. So like I said, I'm not a permafrost scientist, so I'm not going to go too far into depth here, but just to know that the active layer thickness that we are kind of focusing on is really important. So as kind of temperatures, permafrost temperature raises, the active layer is also going to increase. And as that active layer deepens, organic matter is going to thaw and decay, atmospheric CO2 and methane are going to increase, which then kind of has this feedback for climate change and things like that. So here's a major impact that permafrost and changing permafrost is going to have for climate change. Changing permafrost is also going to have major implications for human physical infrastructure. You can see some of the destruction that has gone on throughout the Arctic of what happened as permafrost changes. You can see this is pretty devastating for many Arctic communities. So really understanding how permafrost is changing is important not only for understanding climate change, but also for people living on the ground in the Arctic. So permafrost is important, but we have a problem, right? Data is scarce. As I mentioned, our essential climate variables that we're focusing on are that active layer thickness and permafrost temperature. Not surprisingly, there are challenges involved in that. So remote sensing to understand these variables is limited, which kind of compounds on the fact that in situ data is hard and expensive to collect. We all know that traveling to the Arctic is expensive, and then you saw that person with a jackhammer trying to get through permafrost. Essentially trying to collect these data are difficult, but people have been doing it for a long time. So we do have measurements of thousands of sites. So Permadata Project goal, how do we maximize reuse of these existing data to really more fully understand what is going on with permafrost across the Arctic? So not surprisingly, there are going to be barriers to data reuse. And as I was thinking about this slide, I said, well, this isn't unique to permafrost. We've all seen a slide like this for a lot of different disciplines. I see it, I'm an archaeologist. I see it in archaeology. I see it across the social sciences, across a lot of different disciplines. So not surprisingly, our data are scattered across the internet. We have inconsistent formats and technology. We have data in Excel spreadsheets and access databases, inaccessible in a gray literature report on someone's desk that hasn't been digitized. So how can we, as informatics people, as cyber infrastructure people, how can we start to pull these various data sources together to make the science on permafrost more powerful? So, Permadata goals. We have 4 distinct objectives to try to make that happen. The first one is data integration. So as I kind of alluded to in the last slide, we really want to take historical or currently inactive sites into the global terrestrial network for permafrost through cyber infrastructure tools. And I'll go into each of these objectives in more detail on the coming slides. The objective number 2 is creating a semantic infrastructure for standard variable naming and ontology to be able to link all of these varied data sources together. Objective number 3 is a system integration of our various Arctic data portals that are out there. So we're focusing here on the GTMP, the Global Terrestrial Network for Permafrost, metadata, the Arctic Data Explorer, and the Arctic Observing Viewer. So thinking about linking them together to make discoverability of these data increased. And then finally, to provide some visualization services for GTMP. So if you as a scientist want to go and visualize where data are, different variables of those data, you can create some publication quality maps for either your publication or for policymakers who want to put it in a report and things like that. So those are our 4 ambitious objectives that we were moving towards right now. And here is just a little schematic showing you how we're moving forward with those. So objective 1, once again, data integration from the Frozen Ground Data Center and the Acatus Gateway, which was formerly located at NSIDC, integrating with the semantics, and then meeting the other objectives with system integration and visualization services. So 4 ambitious objectives, and here are some distinct deliverables that we hope to achieve with those objectives. So first, to create a tool to assist bulk ingest and transformation of data into the GTMP system. As you can imagine, if we're talking about lots and lots of data that are in lots of different formats, we're going to need something to automate that process to make them all standardized in some way. We want to expand vocabularies and ontologies to link data sets that have been collected by different researchers using different terms and things like that. We want to add 15 key data sets to the GTMP system, journal quality maps and visualizations. And all of this is hoped to increase data discovery, access, and reuse, and support the long-term goals of the International Permafrost Association and GTMP, and then link various Arctic data portals and centers to make data widely available. So here are 15 different data sets that we're working on incorporating into Permadata right now. These data sets were chosen because there are networks of sites that are obviously not included in GTMP already. They're long-term records, as you can see from the dates on these data sets. Many of them span decades, which gives you a really nice longitudinal view of how permafrost is changing over time. And they're discontinued sites or projects as well. So these 15 data sets were chosen to really enhance the permafrost data that are already located within GTMP. So we're focusing on these right now. So the GTMP is really the primary data source for the permafrost community, and it was just kind of a natural fit for Permadata to partner with them. And you can see some of the sites that they're focusing on right now, and just to give you an idea of how many sites that we are adding to the GTMP. So once again, this is objective 1, right? Data integration. Those 15 borehole data sets that you saw a couple of slides ago consist of 1,500 sites, which is pretty incredible. You see in blue the current GTMP sites, and then you can see in the kind of yellows and reds and browns the additional sites that will be added to GTMP through the Permadata project. So you can see how much more data across a very wide scale are going to be added to GTMP through this project. This data integration is occurring through the data integration tool that Kevin is currently working on. I'll talk a little bit more about that in a couple of slides. We have 1 of the data sets complete with 133 sites already. 3 nearly done, which consists of 270 sites. But at this point, it's anticipated to go much more quickly as these sites are kind of put through the automation process of standardizing. As you can imagine, the first site, the first data set was pretty painful to go to. It's kind of the pilot debugging of the data integration tool. So it took quite a bit of time to figure out how to best structure the tool to make this happen. And now that that's done, the tool has been largely debugged. It's going much more quickly. So we anticipate these sites to be integrated into GTMP much faster now. So this is what I was just talking about as the data integration tool. Essentially, it's a tool to format, organize, and clean and manipulate data files. So as you saw in the previous slide, we really needed to do a lot of debugging for this tool, but it should go a lot faster now. But this tool is really aimed at standardizing things like Fahrenheit versus Celsius, whether you're using meter or feet, and pulling out the active layer thickness and temperature data, and just making sure that they're all in standardized units and measurements so we can link and aggregate these data much more efficiently in the future. So objective 2 is the semantic infrastructure. This is being led by Peter Pulsiver. So once again, knowing that we might have a diverse group of people on the call, I just wanted to kind of go over quickly what we're talking about with this. So semantics is the meaning of the words of the data that we use. And Peter's working on creating an ontology, or a model of concepts, terms, and relationships that can be used to document and understand domain semantics for permafrost community. So really what this means is that we really need to create this ontology to ensure that true sharing across these different data sets, which are undoubtedly collected by dozens, if not hundreds of different researchers, calling terms different things. So for example, a simple case would be whether people are using Celsius or Fahrenheit, and a complex case would be what people are calling different variables of permafrost and things like that. So Peter will be working on identifying terms appropriate for standardizing this terminology. So objective 3 is what I'll be leading in this project, or system integration. So what's really innovative about our model, which I think is really cool, is that it's integrated, modular, distributed, and partnered. So we're connecting a lot of different, very specialized Arctic data services to be able to make sure that these data are linked and fully discoverable to a bunch of different audiences. So we're linking things like the Frozen Ground Data Center, GTMP, and the Arctic Observing Viewer to ensure that these data are being linked across multiple different systems. So the use of legacy data that are highly valuable to understand change in the Arctic can be more widely available to different audiences depending on what tool that they use. So objective 4 is the visualization toolbox. So for those of you who have been on the GTMP website before, there is a search function, but we're working on creating a visualization toolbox in which you'll be able to search for different data sets based on a couple of different variables that you see on the slide here, and then be able to visualize or create maps of different permafrost variables that you might be interested in doing. So this is ongoing at this point, but it will be a very cool product of Permadata in the coming years. So we have a very cool informatics cyber infrastructure project on our hands right here, which is very exciting, but really what this is supposed to do is to enable scientific research on permafrost, right? We want to improve the research workflow for permafrost scientists. So objective 1, or that data integration tool, is really to allow us to identify, access, and integrate those the active layer thickness and temperature of permafrost. So that fits objective 1. Objective 2, or creating that semantic infrastructure, helps to standardize how we're sharing the data and what we're calling different variables of permafrost. Objective number 3, or the system integration, allows us to share those data across to many different audiences. And then objective number 4, or providing the visualization services, allows us to analyze and create maps of permafrost across the Arctic. So lots of really neat science products coming out of Permadata. So we have these great permafrost products coming out. Really, it can enable things like permafrost warming. You see here a couple of different sites going down through Alaska, and you can see mostly we're just being able to, if you have more data, you can have a much better idea of what's going on with permafrost across a number of different sites and be able to make your interpretations about permafrost much more powerful. So just really understand how permafrost is warming through time. And this is the really important aspect of the legacy data as well. When you're incorporating data from the 1950s and 1960s, you get a really, really nice temporal view of how permafrost is changing over time. And then finally, there's been a lot of permafrost modeling occurring and trying to understand how permafrost is going to change in our increasingly unpredictable climate and our environment. And models are just stronger with more data and more high-quality data. So really with Permadata providing better data, high-quality data that's been standardized, it really just makes it easier to make stronger models when it comes to changing permafrost. So with that, I will hand it over to my colleague Lynn to talk about her role.
Thank you so much, Colleen, and thank you to everyone for this chance to talk a little bit about the big picture. I think the really exciting thing for me about the Permadata project is really looking to effectively and scientifically accurately bridge that gap from a single data set in a single location to a more community-wide resource. And we all know that's hard to do, and it's hard to do well. So I feel like the Permadata project is doing some really exciting work, especially with this partnered model between permafrost scientists, cyber infrastructure, developers. Having all of those viewpoints at the table, I think, is a really exciting way of creating products that are actually useful and that can make an impact. So what I'd like to do is then take those products and look at that impact and then scale that up. Keep going. Let's just keep going. So what we're thinking about with our Research Data Alliance is how to engage communities like the Permafrost community and then say not only are Permafrost data valuable within this context, but perhaps they're also very useful from a global carbon modeling perspective or looking at ocean-side erosion studies. So how can we take these really valuable, well-done community resources and make them valuable in a much broader context? So this is what I believe the Research Data Alliance can start bringing to the table. Because what we're focusing on in the RDA are the social and technical bridges that do that work. Because this is work, right? You can't just take a file from someone's desktop and apply it in a global context. At each point along the way, you need to do work to translate, to mediate, to transform both the technical representation of that data as well as the social understanding of what those data mean. So what we're doing in the Research Data Alliance is really looking to build those social and technical bridges. So here's my official RDA slide. Accelerating the development of infrastructure worldwide is the mission of the organization. We are a global community. We are looking at that community-driven aspect. We're very structured in a very bottom-up way. Again, building those social and technical bridges and the infrastructure to enable data sharing. We're a relatively new organization, just launched in March of 2013, but since then we've kind of grown precipitously to over 4,000 people. We've got 110 countries represented, people from industry, people from academia, people from governments, nonprofits, NGOs, a lot of different people from many different domains all coming together with the same goal. I want to point out that to me, one of the exciting and different things about RDA is that we want to do stuff. We don't just want to talk about things. RDA is very much driven by products, by outcomes, by moving the needle. We're an organization that wants to make a difference and make a change, so I wanted to highlight that building section. Now, the way RDA operates, we have regions that contribute to this global model, and so this is where, to me, an Arctic conversation and indeed a permafrost conversation can come into play. So with a regional effort, there are folks working in regional efforts, in regional ways, in regionally funded projects towards common issues. So, for instance, data citation, there are United States groups working on this issue. There are Arctic groups working on this issue. However, can we then take that regional work, can we take that regional expertise and elevate it and combine it into a globally synergistic community and set of products? So this is kind of the way RDA operates, and it's, to me, it's very effective in the sense that the needs of the people on the ground are often regional. However, the issues are global. So what we can do is try and find the synergies between those and try and find the connection points to make that work better and to make it easier. So, for instance, from the United States perspective, the United States RDA region is a coordination mechanism. We can facilitate projects, we can facilitate funding, we can facilitate connections with the global RDA system, and here are just a couple of examples in terms of work that we're currently doing in the United States to support and facilitate the global RDA community. So what we found, again, given the funding mechanisms, given the regional needs, given regional politics, given regional approaches, what we can do is facilitate those on a region scale and then connect those to a global community. So let's talk about the Arctic a little bit. The Arctic data community, the Arctic science community, the Arctic community in general is doing some amazing work in the sense of metadata, in the sense of infrastructure, in the sense of systems, standardization projects, open data sharing. So what are the kind of pros and cons, and what are the potential connection points with a more global community? What RDA can bring to the table? We've got a lot of people. And they're all working on this stuff. And again, coming back to that sense of wanting to do things, these people are engaged. We've got meetings, we've got outcomes, we've got recommendations. People are moving forward. So that's something that the Arctic community can leverage in some way. We are structured through this idea of working groups. Currently, we've got 29 international working groups looking at everything from infrastructure interoperability to metadata standards, brokering, persistent identifiers, privacy implications, all these very cross-discipline, cross-nation, international issues with potential implications for regions like the United States, for regions like the Arctic. We are a neutral venue. We've tried very hard to stay out of the game of endorsing any particular technology, any particular region, any particular group, in favor of, again, that community-driven process and outcomes, in the sense that the products RDA is coming out with are community-endorsed, and as opposed to kind of authority body coming in and saying, you shall do this. It's very much a bottom-up driven approach to reconciliation of all the challenges, of all the diversity that we've got in our data world. We do have some administrative and support services for achieving this stuff. For instance, me, I'm full-time employed right now, and one of my tasks is to support the U.S. community in doing this work. So when I think about RDA in the Arctic, I get really excited. The Arctic is, again, doing amazing things, and from a global perspective, the implementation little microcosm of the Arctic is unique and critical globally. I feel like the Arctic is way ahead of the curve in terms of bringing together interdisciplinary data, in terms of looking across communities, in terms of coming up with that regional view of the world. And not many others are doing that. So I think there's a lot that you all can bring to the table in terms of a global conversation. Again, this interdisciplinary lessons learned, this work is hard. You all know that. You've been there and are slogging through it. And it would be fantastic from my perspective to kind of share that more broadly. And again, making sure that the polar perspective is included in broader conversations, to me, is a really valuable thing that I feel like we can improve on. So at the end of the day, I would love to work with all of you. I encourage all of you to come and check us out. If there's something that I can do to help you figure out if and how you would fit or want to fit, please let me know. I think there's a lot of opportunity here and a lot of really cool work that we could do and that we could do together. So with that, I think we can close up. Our contact information for Colleen and I is up in that left corner. I would really encourage all of you to check out International Data Week coming up in September, held in Denver, Colorado. We're bringing together 3 different international data organizations that haven't come together before. It's going to be a fantastic week, a really exciting week, and I think a unique opportunity to showcase the work that you're doing. So with that, I think we will stop there and see if there are any questions.
Thank you very much, Colleen and Lynn. Colleen, you did a great job of describing to us a really hands-on project that's looking at a particular type of science and particular type of data. And thank you, Lynn, for tying it all together and bringing it up to the international level. I know that's of great interest with a number of groups that are focused on the Arctic, the Arctic Data Committee, and also IARPIC, the group that we're actually presenting within here. And within IARPIC, I think there are many of these challenges you talked about, is how do you cross the domains, how do you cross agencies, et cetera, and really try and work together. So with that, I will open the floor up to questions. If anybody has questions for Colleen or Lynn or both, please present them. We have had some difficulty with the audio. So if you're trying to speak and it appears that nobody's hearing you, then please use the chat window and we can relay your question in that way. And thanks again to both of you.
Thank you for having us.
I don't have any elevator music to play while we wait for questions. But
sure.
I see.
I've got a question.
Great. Go ahead, please.
Oh, can you hear me? Oh, okay, it's Sandy.
Can hear you.
Great presentation. One of my questions, having addressed the sort of atmospheric science side of this, of like in particular Elkin's interest in the carbon cycle aspect of this problem, is we hear a lot the need to be documenting the ancillary data to characterize the site where some of these observations are taken. To what extent did you dig into ancillary data and site characterization in this work versus just focusing on the key variables?
I'll jump in. Colleen and I are here nodding to each other. So as part of the original proposal, one of the goals was to look at 15 data. 15 was kind of an arbitrary number. The thought was to pull as much diverse permafrost data as we could to facilitate that cyber infrastructure development. We wanted to pull data sets that were going to be
Sorry, we can't
critical.
hear Lynn and Colleen.
Oh.
We can.
Oh, we can hear you guys.
Can everyone else hear us? Is it a problem on?
I can hear you, Lynn and Colleen. This is Jessica.
Okay.
I'll go check on Sarah.
All right.
Thank you.
Well, so I guess to answer Sandy's question for everyone else.
It's recorded, it's okay.
Exactly. The thought was to highlight one data sets that were going to fill in regions that weren't currently well covered under existing permafrost maps and the GTNT. Two was to look at data sets that had temporal significance. So longer time series and more sites were better. We did not specifically go into ancillary data. The thought was to facilitate more of an updated map and permafrost data resource for modeling, for matching up with remote sensing for other uses. So we did not get very far into the ancillary data question, although I completely agree that it's a critical one moving forward.
I can see the ancillary data being something like Permadata 2.0, and that we're focusing on 2 very specific variables with 15 specific data sets to really figure out how this all works. And then the next iteration of these projects can really focus on expanding to even more sites and even more different types of variables that are going to be important for permafrost scientists.
Mm-hmm.
Okay, thank you. Do we have any other questions for our speakers? Okay, I will just kind of monitor for a moment or here as well. We have a couple of other agenda items we can move on to, but before doing so, I'd like to say thanks again to Lynn and Colleen. This presentation has been recorded and will be posted on the IARPC collaboration site probably within a couple of weeks or so. And we also have the ability to take questions through our other agenda items that we're going to cover in the next few minutes. And then through the IARPC collaborations website, there's the Arctic Data Collaboration Team component of that, and so you're welcome to join us there and put out questions or comments there.